Yeah. Yeah, good evening all. So myself, I'm Vijay. Like I hold like 17 plus years of experience, which includes nearly 8 plus years of experience in big data environment, right? Hadoop and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir.
Fine. So big data, right? Yes. Hadoop and PySpark. Okay, as part of today's demo, I'll be covering the following topics. What is big data? Why Hadoop and Spark? Why Hadoop? Drawbacks with current databases. Need for PySpark. Real-time use case. Hadoop and PySpark job market, right? Yes. Yes. One second. Yeah. So big data, right? The name itself saying, right? Huge volumes of data, right? Big data, the name itself saying huge volumes of data. Currently, the data is getting stored. How the data is stored? Like KBs of data, MBs of data, like GBs of data, terabytes, petabytes, exabytes, zettabytes, etabytes, sotabytes, so on, right? Yes. So from TB onwards, we are going to say it as big data or huge data, right? From TB onwards, we say like huge data. Currently, right? You should have seen like KBs of data, MBs of data, GBs of data. Even you should have seen TBs of data. But do you think like petabytes of data, is it getting generated in the current real world? 1 petabyte equal to 1024 TBs, right? Yes. Talk about 1 petabyte equal to 1024, right? TBs. 1024 TBs, right? Yes. Okay. Do you think like petabytes of data or exabytes of data, is it getting generated? If so, examples of petabytes of data generation. Like if you talk about the banking sector, right? Like SBI or HDFC, right? So within the city, you see hundreds of branches. Within the state, entire state, we see like thousands of branches for SBI. Within the entire country, lakhs of branches for SBI. Again, in each branch, millions of customers, each customer making multiple transactions per hour, per day, per week, per month, in a year, right? Each and every transaction need to be stored, right? Each and every transaction has to be stored. So huge. Okay. Forget about this everyone, you are aware about like social media like Facebook, right? It has got users not even within the country, it has got users throughout the world. Millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What is the data generated by Facebook in a minute? Huge data, right? Each and every post need has to be stored. So not in MBs or GBs, it will be in petabytes of data generation. Not only like Facebook, right? If you talk about any application today, it is generating huge data. If we talk about any application generating huge data, for example, I'm sorry, if I take 1 minute transaction, I'm talking about 1 minute transaction. In a minute, how many FB posts? Yeah, Facebook post, right? Yes. What is the data generated by Facebook in a minute? What is the data generated by Twitter? Twitter tweets, right? Keeps on generating. And everyone, they are querying in the Google queries, right? Data generated by Google in a minute. Everyone creating their own videos and uploading in the YouTube, right? YouTube videos upload. YouTube videos upload. Yes. See, once again, the session will be up to this 3 hours, right? The session will be for 3 hours. In the middle, you will have a break, right? Right. So if you got any queries, you can unmute yourself and you can ask the queries. So at the end of this session, I'll be giving time for your general queries, right? Yes. Fine. Here, messages. Up to 7 p.m. The session will be up to 7 p.m. right? In the middle, you will have a break of 15-20 minutes. Okay. Here, Gmail or email messages. Email messages, right? Yes. Email messages, right? What is the data generated? Millions and trillions of users using email messaging, right? Yes. And bank transactions. Just now I discussed about bank transactions, right? Telecom transactions. So bank transactions, like millions of customers making multiple transactions. And here, e-commerce sites like Amazon, Flipkart, right? They're generating huge data. So this is where you each and everywhere, right? Most of the applications generating huge data, not in MBs, GBs, or TBs, in petabytes, right? So as of now, we have got some databases, right, for storing this data, right? We have got databases like Oracle, right? MySQL, DB2, SQL Server, right? These are used for OLTP, online transactional processing, right? And we have got some specialized databases. We have got some specialized databases used for data warehouse purposes, right? Specialized databases used for data warehouse purpose, like if you order like Teradata, Netija, Vertica, right? These are used for data warehouse, DWH, OLAP, analytical processing. Yes. But we doesn't, these databases, specialized databases can handle data up to some extent. They can handle data up to some extent, right? Yes. Yes. Okay, OLTP. They can handle GBs of data or TBs of data, right? Beyond that, they cannot handle data, right? So we doesn't have proper storage system and processing system, right? Which can handle huge data or unlimited data, right? As a solution to that, all the storage level problems and processing level problems, we have got a framework called Hadoop for that. Later, I'll come back to that. But before that, you need to know how this data is getting generated, what are the data generation and their sources of data and types of it, right? Before we go with the services of Hadoop. Fine. So if I take the entire data in the current world, see, this is the data in the entire world, which got generated from the last 50 years, from 1973 to 2023. This is the data, right? But if we right, if you see the data, especially from the last 10 years, 2013 to 2023, compared with the previous 40 years, previous 40 years and the last 10 years, right? Nearly 80% of the data what we see, right, has been generated from the last 10 years, and previous 40 years only 20% of the data. The reasons which for huge data generation, especially from the last 10 years, because of usage of technology, usage of smartphones, and usage of internet. Today everyone has got internet, right? You are carrying internet. Huge data is getting generated because of these smartphones, internet, and tech. And what are the main sources from where this data has been generated? Means mainly I can say three sources of data, right? Yes. Social data, machine data, and transactional data. Social data, machine data, and transactional data. Social data means data which got generated from social sites like Facebook, Twitter, YouTube, all this, right? Machine data means data which got generated by reading or scanning the barcodes, RFID chips, right? Yes. So whenever you go to a shopping mall, for the items you purchase, you will get a big, huge bill, right? Yes. So by reading or scanning the barcodes, that's such kind of data we called as like machine data. Transactional data, day-to-day operations like telecom transactions, bank transactions, right? And this data which got generated is going to occupy mainly, that's going to say like three types of data, right? Yes. Like structured data, semi-structured, and unstructured. Structured data means data which is organized in the form of rows and columns in a structured manner, right? Structured data which is organized in the form of rows and columns in the structured manner, like database tables, DB tables, Excel files, database tables, Excel files, right? Yes. Semi-structured means data which is not fully structured, which is not fully unstructured, like XML data, JSON data, right? And unstructured like chart messages, articles, images, videos, all this comes as unstructured, right? But the biggest challenge today, right? Most of the data, what it is being generated is of unstructured or semi-structured format, right? But if you talk about the current databases, they can handle only structured data, right? But semi-structured, unstructured cannot be handled. So we need to have a proper tool which can store and process this data, right? So as a solution to all these storage level problems and processing level problems, right, we have got a framework called Hadoop. We have got a framework called Hadoop. Hadoop providing two services, right? Storage and processing. It provides two things for storage and processing. So generally, if you talk any technology, right, either C or C++ or Java or .NET, all this they are meant for processing. Or if you talk like Oracle, MySQL, DB2, all these they are meant for storage, either for storage or for processing. But Hadoop is meant for both storage and processing. So you may get a query, right? When Hadoop is able to perform the storage and processing, what is the necessity of these technologies? So when Hadoop in the market, do you think these technologies will be away from the market, right? No. You need to understand Hadoop. Hadoop is for batch applications. Hadoop is for batch applications. Hadoop is not for online applications. It is not for online applications. It cannot perform online applications. It can perform batch application. If you are performing a single transaction, for that Hadoop is not required. For a single record, for 2 records, for 10 records, Hadoop not required. For millions and trillions of records, storage and processing, we go for this. Okay. So yes, I'll come back like this batch and online applications, but uh, for storing the data, Hadoop doesn't use any database because databases has got some drawbacks. Despite with the drawbacks, still Hadoop doesn't go with the databases. So it is going with a kind of file system called as Hadoop distributed file system. And for processing, we are going with MapReduce, but currently we are using Spark. MapReduce and Spark both are used. Yes, so Hadoop, two services, storage and processing. For storage and for fine. Hadoop providing two things. One is storage, HDFS, and for processing, yes, MapReduce. So there are two types of applications. Hadoop is meant for batch applications. Hadoop is meant for batch applications. You may ask, what do you mean by batch applications? There are two types of applications. There are two types of applications. First one, online applications and batch applications. Second is like batch applications. Right? Yes. And batch applications. What is the difference between these two? Online applications, batch applications means online applications, user interactive applications. User interactive applications. Here user gives the input. Here user gives the input. Example of this online application, booking a, making an online transaction. Say, booking a movie ticket. Okay. And for a batch application, here user is nowhere required. User non-interactive applications. User non-interactive applications. Here user is nowhere required. User is nowhere required. Example, right? Your railway ticketing PNR status. Currently your status is 200. After 1 hour it is 170. Today night it is like 100. Tomorrow morning, tomorrow afternoon it is like 50. Tomorrow evening you got confirmed. Means it is a batch application which is running in the background. Here user doesn't give any input, right? It happens automatically, right? Yes. Or examples, right? Credit card statements for millions of customers. Credit card monthly statements, right? For millions of customers. For this, user is nowhere required. User doesn't give any input, right? Yeah, it. Mobile bill. statements for millions of customers. So all these are batch applications. So most of the financial applications, right, are bank applications, right? They are batch applications, right, which will be running in the background, right? And why databases can't be used for storing these Hadoop's data means there are drawbacks with the current databases. Drawbacks with the current databases. Right. First thing is limited storage in most of the databases, limited storage. And secondly, no parallel processing in most of the databases. And thirdly, right, if volume increases, speed is decreasing, right? If volume increases, speed decreases, right? Yes. If volume increases, speed decreases. Select sum of amount, total amount from, select total amount from sales one. Select sum of amount from sales one, total amount from sales one. Think you got some 10 records in this. Select total amount, right? Total amount from sales to, you got some 1 lakh records. Select total amount from sales 3. 1 crore records, right? Yes. Total amount of sales 1, total amount from sales to, total amount. 3 tables I got. In that 10 records are there. In that 1 lakh records and 1 crore records. Which query is going to execute faster among these 3, right? Total amount of 10 records, or total amount of 1 lakh, or total amount of 1 crore?
10 records.
First record, right? That is what total amount of 10 records. Total amount of 10 records. Okay. So query to query, as this volume increasing, speed decreases, right? Yes. And one more, like complexity increases. If complexity increases, right? Yes. Speed decreases. Right. Select. So if I take the same, select sum of amount from sales 1, right? Yes. See, this queries complexity increases, also speed decreases. For example, total amount from sales 1, total average amount from sales 1, AVG, standard deviation of amount from sales 1. So same table, right? Yes, same table, standard deviation of amount from sales. So here, which query is going to execute faster among these 3 for same number of records? Average amount is a 2-step process. First sum to be calculated, next average to be calculated, takes more time as compared with the first query. Standard deviation of amount, right? Standard deviation of amount, right? Lot of internal processing required. Lot of internal processing required, right? Yes. Yeah, fine, right? Yes. So query to query, yes. So query to query, as complexity increases, speed decreases, right? Yes. Next, the major drawback with databases, right? Yes. Databases can handle only structured data. The major drawback is databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, can handle only structured data. So for example, observe. I want to take reviews for a particular movie, right? Yes. So I'm just taking this. Yes. Reviews. My table name is reviews. Taking reviews of a particular movie, right? Reviews. So I got some two columns, user and the review. User one, user two, user three, 100 users, right? Review one. First person saying the movie is good, saying second person saying the movie is bad, saying movie is good. Means they are giving the feedback in the form of zeros and ones. They are giving the feedback reviews in the form of zeros and ones, one and zero. Zeros and ones, right? Yes. So here, okay, can you write in SQL query to count the number of zeros and ones here? Yes. Can you write an SQL query to count the number of ones and zeros? Count aggregation. Select a review wise count I want. Count star. From which table? From reviews table. Group by. Select review comma count star from reviews. Group by review. Group by what? Review, right? Yes. So the output, right? Yes. Output will be like 0, 1, right? 90 people saying the movie good, 10 people saying the movie is bad, right? But generally, the reviews won't be given in the zeros and ones. They provide the feedback in their own text format. First person saying movie is good. Second person saying like movie is not good, right? So in this way, they are writing in their own text format. Now, can you count the number of people saying goods and not goods? Even by using keyword count. If you perform right, it's wrong computation because even not good has got a good within it. So this kind of data can't be handled by the databases. So they can handle only structured data, right? So next is advantages of Hadoop. Before I go with advantages of Hadoop, right, let me just demonstrate, right? I'll give overview of Hadoop architecture. Later I'll discuss in brief Hadoop storage architecture and processing architecture. Hadoop follows master slave architecture. Master slave architecture, right? Yes. It follows master slave architecture. Hadoop is not for client server. Hadoop is not for client server architecture. It is not for client server. It follows master slave architecture. Okay. So here, observe this single master and multiple slaves. Hadoop has single master and multiple slaves. This is the master, single master and multiple slave nodes. Multiple slave nodes, right? Yes. S1, S2, so on up to Sn, right? Slave 1, slave 2 up to slave n. Okay. This is master node. These are slave nodes. Slave nodes. Slave nodes means systems. See, this entire thing we call like a cluster. A cluster. So here, okay. What do you mean by Hadoop cluster? Group of nodes connected in a network. Group of nodes connected in a network, right? Okay. See here, this we call as master node, slave node. So see, if I talk about a file f1.txt, huge data, right? f1.txt file. Nodes means systems. Group of nodes, CPUs, can you say right here? Group of nodes means CPUs. Group of nodes, CPUs connected in a network systems, right? Connected in a network. There are two types of nodes, right? Yes. Master node and slave nodes. See f1.txt, that each slave node capacity 1 TB, 1 terabyte, 1 terabyte, 1 terabyte. But this file capacity 2 TB. This 2 TB file cannot fit into any of these slaves. Means none of the slaves can accommodate this f1.txt file. So it is dividing into multiple partitions. It will be divided into multiple partitions. First partition in slave 1, second partition into slave 2, third into slave 3. Slave 1, slave 2, slave 3. See, cluster means I clearly am saying group of systems connected in a network. There are two types of group of systems connected in a network. There are two types of nodes, master node and slave nodes. So this file is divided into smaller parts and they are distributed across multiple systems. So here, two things you need to understand here. Your huge data object file divided into smaller parts, they are distributed across multiple systems, slave systems, right? And are processed parallelly. Two advantages what you observe here. Two advantages what you are able to observe. Distributed storage means the huge data file can be fit into or can be accommodated, and that huge data file is processed by multiple systems parallelly. Means the data in each system, some lakhs of records are stored and are processed parallelly, right? Yes, that's why high speed you can see in Hadoop, and huge data can be stored, can be accommodated, right? Yes. You may ask, everything the storage is done by the slaves, processing also done by the slaves, then what master does? Master is going to assign the task to the slaves, T1 task to it, T2 task to the slave to T3 tasks. Task assignment and load balancing the load equally to all the slaves. If any slave goes down, then the task of it need to be assigned to other slave. The task also done by the master, right? Yes. Now coming to this, right? Hadoop advantages, right? Hadoop advantages. Hadoop advantages means unlimited data storage. First thing is what? Unlimited data storage. Very high speed processing. Very high speed processing. Unlimited data storage, very high speed processing, right? And can handle all varieties of data, can handle all varieties of data, structured, unstructured and semi-structured, right? Yes, can handle all varieties, right? Open source, no licensing required. Open source, no licensing is required. Okay. So unlimited data storage is possible because of there is a feature in Hadoop, right? Horizontally unlimited scalability. Horizontally unlimited scalability means horizontally unlimited number of slaves can be added. Horizontally unlimited number of slaves can be added. If your data is increased, if your data is tomorrow, like your business is increased, branches have increased, customers are increased, data is increased, means if data increased by 100 times, customers increased by 1,000 times, right? We cannot go with the same number of slaves, right? We need to increase the systems for storing the data, right? Very high speed processing because of parallel processing, right? As your data is distributed across multiple systems and are processed by multiple systems, right? We see very high speed processing, parallel processing, right? Yes, can handle all varieties of data, structured, unstructured, and semi-structured of data. Yes, there is an example, right? Yes, Yahoo has conducted a test to check the speed of various databases. It has taken a task, right? Yahoo has taken a table of 1024, right? 100 TB consisting of 1024 columns. So the task is sorting based on 16. Task is sorting based on 16 columns. Sorting based on 16 columns, right? Yes. So what is the time taken? What is the time taken by different databases? Right? Oracle has taken, right? Oracle has taken, right? Nearly 3.5 days to process it. MySQL has taken, right? Yes. Six days. Okay. Teradata, right? Another specialized database used for data warehouse purposes. Teradata is used, like has taken just 4.5 hours, right? And one more specialized database used for data warehouse purpose, like Netija, has just taken 3 hours, right? And finally Hadoop to process this, right? Hadoop has just taken 3.4 minutes. Latest version of Hadoop has just taken 1.2 minutes. This is what Hadoop is proven in the market processing point of view, right? With very high speed as compared with the other things, right? Yes. So ETL kinds of technologies, right? ETL kinds of projects are getting migrated towards Hadoop environment where we see huge data and processing. And storage point of view also, you may ask, I will a query, right? Why databases like Oracle cannot support unlimited storage, right? While databases like Oracle cannot support unlimited storage, means even in real time, right? If a Oracle database, other things, we can go with multiple slaves. So here databases, and what is the limit on the number of slaves? There was some limit on max number of slaves. Limit on max number of slaves. For example, Oracle, right? Oracle, it can go with max 256 slaves. Means nodes or systems. Systems, right? Yes. Nodes are slaves or systems, whatever I say, right? Fine. Just now I taken one example of unstructured data, right? Taking reviews. Okay. And the semi-structured data means like working with XML data, JSON data, right? And MySQL as just can max limit on max number of slaves means max it can go with 54. Can go with 54 systems or nodes, right? 54 nodes. And MySQL Express. MySQL Express can go with 256 systems or nodes. Okay, 250. And apart from this, right? Any database like DB2 has taken, right? 256 nodes are slaves or systems. SQL Server also, right? It has taken the same. Max, it can go with maximum 256 slaves or nodes, right? For storing its data. Once they get filled, they cannot support data, right? They cannot store data further. But if you talk about the specialized database like Teradata, right? It is going with 512 systems. 512 systems for storing its data, right? 512 nodes are slaves for storing its data. But Netija, another specialized data warehouse kind, Netija. It also can go with 512 slaves. And Vertica, one more, right? It is used for data warehouse purpose. It also can go with maximum 512 slaves for storing its data. But currently they are going with Teradata and Netija. Currently they are supporting 1024, right? Slaves or systems for storing its data. This Netija also can go with 1024. But 1024 also, I cannot say like huge data, right? Unlimited data is not supported. Once the 1024 slaves gets filled, they cannot support data further. But there is no limit. There is no limit on the number of slaves that Hadoop can have, right? There is no limit on the number of slaves that Hadoop can have. Okay, yes. No limit on the number of slaves that Hadoop can have. It can go with unlimited number of slaves. Yahoo, when first time implemented Hadoop, right? Yahoo, when first time implemented Hadoop. Hadoop, it went with 4,000 slaves for storing its data. Systems are nodes, right? Currently, right? Yes. Currently, it is going with 12,000 slaves for storing its data. Facebook, right? Facebook, when first time implemented Hadoop, it went with 8,000 slaves. Initially, it went with 8,000 slaves or systems for storing its data. Currently, right? Yes. Currently, it is going with 42,000 slaves for storing its data, right? Yes, Facebook. So there is no limit on the number of slaves where databases can store with 256, specialized databases like 1024, but Hadoop no limit, unlimited number of slaves are supported, right? So that's why there is no limit. So Hadoop is proven in the market, storage point of view, processing point of view by storing huge data and for processing huge data, parallel processing, right? Yes. So that Hadoop has got great boom today, right? And if I talk about this PySpark, right? Okay. What is a Spark? First, like what is Spark? Right. It is a open source. Spark is a open source distributed cluster computing framework introduced by Apache Software Foundation. It is a general engine for all the big data analysis, processing, and computations, right? Yes. Okay, I can say like Spark and need why PySpark means it is a Python API to use Spark. So if I talk about what is PySpark, it is a Python API to use a Spark. Spark is a yes. Spark is a writer. Open source. It is an open source cluster computing distributed in-memory computation right, with parallel process with in-memory computing feature with in-memory computation feature with in-memory computation feature, right? Yes. Open source cluster computing distributed in-memory. In-memory computation means your storage and processing both happens within the RAM. Storing within the RAM and processing within the RAM, right? Yes. So I can say PySpark is a lightning fast technology, right? That is designed for fast computation. So PySpark has got a very high demand among the data engineers, right? To work with bigger data sets. So PySpark mainly we use for what purpose? PySpark uh, is used for PySpark is used for distributed SQL, right? Distributed SQL, creating data pipelines, for data ingestion into database, for machine learning algorithms, graph and for stream, graph and stream algorithms, right? Graph and data streams, right? Yes. So if I see what is the need for PySpark, what is the necessity and need for PySpark? So if you see a large amount of data is generated both offline and online, right? So this data contains hidden patterns, unknown corrections, market trends, customer preferences, useful business information, which is necessary, right, to extract useful information from this data. So we require some efficient tools to perform different types of operations on this huge data or big data, right? There are some various tools already available. They have got many tools there to perform this, right? Operations on huge data sets, but those tools are not so appealing. So we need to have some scalable and flexible tools. We need to have some scalable and flexible tools, right, to crack the big data and gain benefit from it, right? So PySpark is such a kind. So we combine both Spark and Python, right? We both combine Python and Spark would be the very efficient way for the world of big data, right? Yes. So the combination of Python and Spark will be the very efficient for the world of big data, right? Yes. That's why like Apache software community, right? They came up with a tool called PySpark, right? Python API for using Spark. Okay. So most of them, like even if you talk about Spark, for Spark, Python and Scala both are used, right? Python and Scala both are used, right? So which is the most preferable Python if you talk about Python and Scala, right? Python is dynamic typed. Scala is static type. Scala is static type. Means what do you mean by dynamic type? Means no need to say directly. I can say X has 10, Y has 4.5. Means what is the type of Y? What variable Y is? Means as you have assigned float value, it's a float variable created. As you have assigned integer value, integer variable created. As you are assigning string variable is created, right? Secondly, right? Python has a huge community, right? Yes. So here Scala has a smaller community, right? Yes. Python supports nearly 89,300 inbuilt modules, right, for various domains, right? But Scala little less. So there is no concept of models here, right? Libraries are less as compared with Python, right? See, in all, I cannot say that Python is great always as compared with Scala, right? Python is slower than Scala. Okay, Scala is faster than Python. Okay. So what is that real life usage, right? Real life usage. Real life usage of PySpark, right? For where it can be used means in commercial sector, right? In commercial sector. So if you talk like Apache Spark real-time processing system, right? So banks and other financial fields use Spark to retrieve customers' social media profile, right? To gain useful insights, which can help them in taking right decisions, and also in fraud detections, right? And also in healthcare, mostly used in healthcare also, right? Spark is used to analyze the patient's records along with the previous medical histories, right? And also identifying or predicting which patient is likely to face the health issues even after being discharged from the clinic. Even like entertainment industry, right? Entertainment industry, right? Yes. Okay, entertainment industry, right? Yes. It's one of the largest sector, right? Which is towards the online streaming, right? Even like if we talk today, like Netflix using Apache Spark for real-time processing, right? Just give me a second. Entertainment industry I was talking, right? The Netflix is using Apache Spark for its real-time processing. for personalized online movies and for web series. And it processed nearly, right? It's Apache Spark is processing nearly 450 billion events per day that are streamed over server-side applications, right? Even in e-commerce site, e-commerce site, it is mostly used, right? E-commerce. So if you talk like Flipkart, Amazon, all this, they are using Spark for advertising. The other websites like even Alibaba using this for customer experience and optimizes the overall performance, right? Yes. And for tourism industry, right? Yes. The tourism industry widely uses Apache Spark to provide advice to millions of travelers, right? Comparing the hundreds of tourism websites, right? Yes. So main features of Spark, if I talk about the main features, right? Main features of PySpark. Features of PySpark. First thing is in-memory computation, means everything is stored within the RAM memory, right? And processed within the memory. Yes, in-memory computation, storage within the memory and processing within the memory, in-memory computation. Lazy evolution, right? Lazy evolution means lazy evolution means, right? If you perform, okay. Lazy evolution and active evolution means whenever defined or declared immediately, yes, execution. Yes. Lazy evolution. On demand executing, right? If you perform, if you, okay, just like functions, if you make a function call, then only it execute, otherwise it won't execute. Here also our data flows, Spark is a data flow language, right? So to data flows to execute, we will need to perform some action. If you perform action only, it will execute, otherwise the data flows won't execute. The data flows executes only when you perform some action. That is what lazy evoluted. Just like, for example, if you are writing notes daily, right? You are learning, you are updating with the technology, you are writing notes. It doesn't mean that you will be daily reading the notes. When exam is kept, then only reading, right? It means that is lazy evoluted. Active evoluted means daily reading, right? Without exam, right? Yes. Here also the data flows gets executed only when you perform an action. So next is fault tolerance. Spark has got powerful fault tolerance, right? Fault tolerance means as you are running, okay, fault tolerance, as we are running this Spark data objects on different systems, right? And they are distributed across multiple systems of multiple rams of multiple slave systems, and are processed parallelly. If any one system goes down, right, the data is lost. So to overcome that, Spark is providing powerful fault tolerant models, right? And persistence, right? One more important feature is persistence. Persistence means already executed transformations, we can reuse them again, no need to start from the beginning, right? Yes, I'll show you with some examples later, right? And distributed, it is distributed RAM, right? We are using distributed. So your data objects is distributed across multiple RAMs of multiple systems. So, and parallel process. So data is processed parallel process. So these are the main features, right? Yes. So today, like PySpark has it's one of the demanding tool in the market, right? Used by the data engineers for huge data processing within quick time, right? It's open source cluster computing distributed, right, in memory. So Hadoop and PySpark both combinedly can store and process the data. So once, so I'll just show you this course content, right? What I'm going to discuss as part of this, right? Just you can observe this. What is, okay, so first big data and okay, what is big data, need of Hadoop, right? Sources of data, challenges, HDFS, Hadoop distributed file system. We're not using any database, right? And map reduce execution model followed in Hadoop, right? So job tracker, task tracker, mapper face, reducer face, scoop, SQL plus Hadoop. importing data from databases to Hadoop and Hadoop to databases. And we perform many groupings, filterings, aggregations, merging, sorting, incremental imports, right? Yarn, yet another resource negotiator, right? That total how this processing flow. And as a uh, data engineer, right, you need to have at least one NoSQL database. You need to have the idea about at least one NoSQL database, right? Types of NoSQL, and I'm going to discuss database that's NoSQL like HBase, which is especially designed for Hadoop environment, and Hive. It's one of the important tool of Hadoop. So more discussion on this Hive. It's a kind of data warehouse kind of environment where we make data structure and create tables, internal tables, external tables, working with unstructured data, XML data, JSON data, URL, weblog data, right? UDFs, UDAFs, UDTFs, right? User aggregated functions, tabular functions, right? Non-partition, partition, static partitioning, dynamic partitioning, multi-column partitionings, right? Performing tuning mechanisms, right? Yes. Bucketing in Hive, indexing in Hive, right? So Hive and HBase integration, right? Yes. And coming to a PySpark, right? Apache Spark, PySpark session, context objects, partitioning, broadcast variables, accumulators, actions, transformations, and persistence options, different persistence options, and core computations, groupings and aggregations, right? And groupings and aggregations, various actions, one by one actions and transformations, inbuilt actions and transformations of PySpark, and PySpark data frame, right? Using map, PySpark creating empty data frame, converting data frame to pandas, row class, column class, select, collect, right? With column, where, drop, order by, group by, join, union, UDF, for each sample, pivot, all this, right? PySpark SQL functions, aggregate functions, date functions, time JSON, right? Read, write, when EXP, all this, right? PySpark built-in functions. So we don't need to write huge codings in PySpark. We have got many inbuilt APIs. So all this you can write, yes. To join to JSY underscore sample, right? And PySpark external sources, working with SQL statements, Spark and Hive integration, Spark and MySQL integration, working with CSV JSON, transformations and actions, adding to new columns, handling nulls, deployment modes, local and cluster mode, and PySpark applications, TSN task, driver and executor, building Spark application, deploying Spark applications to cluster and tuning performance, right? And PySpark streaming related and integration with Kafka and some part of ML I'll be discussing, right? So this all total like big data, Hadoop and Spark in brief, right? We'll be discussing this. So it's a 12 weekend batch, right? 12 weekends we'll be discussing on this. So it will be like 2.5 daily, like Saturday 2.5 hours, Sunday 2.5 hours, so 5 hours, right, per week. So 12 weeks into 5 hours, 60, right? Nearly like 60 hours we'll be spending time on that. Nearly 35 to 40 hours I'll be spending on this Spark, which is mostly used, right? Remaining on Hadoop components, right? Mostly used. Fine. So you will be getting, as of now, we are going with the weekend batches only. Why? Because it is open to all the job holders, right? They can attend on Saturdays and Sundays, where if you are keeping specific time on weekday, so most of them, right, maybe might be won't be make up for that particular time. So that's the reason to make all the students to attend weekend batches. We are starting, right? Already the other 3 weekend batches running on, right? Fine. So you'll be getting the recorded video every day, every session you will be getting the recorded video, clear notes, soft copy of the notes, right? A WhatsApp group will be created for technical discussion, right? Yes. So the sessions will be interactive sessions. You'll be, you can unmute yourself and you can ask queries if you've got any. At any point of time during the session, you can ask queries. And software I'll be providing, right? No, don't worry about the software. Videos and softwares you'll be getting to your Google Drive, notes to your mail IDs, right? So we'll have a break some for 15 minutes, right? From 15 minutes from here, and again we'll continue from one and a half hour more. Like just like we'll have a break for just like 15 to 20 minutes from here, and we'll have a session of 1.5 hour more, right? Right, up to 7 p.m. right? So before that, if you have got any queries related to this, right, can ask me, right, if you have got any queries related to this Hadoop and Spark.
I have a question, sir.
Yeah, go ahead.
Actually, I supposed to join your PySpark course, which is 8,000 rupees cost one. I think how many weeks? That 10 weeks. Will it be covered all those course content in this course also?
So this is a combination of two courses, Hadoop and PySpark. So here previously only PySpark batch was there, like means this is the extra content, right? Which is Hadoop is the extra thing. So you can see this this entire things whatever I'm discussing, right? This Hadoop is covered up to here. Later comes this is the PySpark. Previously there were some only PySpark batches were there. So as most of the students who doesn't have knowledge on Hadoop, that's the reason we are going with Hadoop and PySpark batch. This batch consists of both Hadoop and PySpark. So the same PySpark who has already means this is the PySpark content. That's content will be the same PySpark entire total all this.
The independent PySpark course will be also same content will covered in this course.
Yes, that whatever that PySpark batch, the entire thing whatever we discussed will be there. But apart from this, Hadoop will be covered.
Extra here, okay. And
Yes,
second question, sir. What is this Azure Data Engineer? People used to use it for PySpark and Hadoop both. Azure Data Engineering and this one difference. Can you please explain?
So yes, whatever. So today like PySpark, right? We are just running on the yarn cluster, Hadoop cluster, right?
Yeah.
We are running this in the Hadoop cluster. You can also run this Spark on the other clusters, AWS cluster and other clusters, right? Azure, all this, right? So mostly we are using in as of now, we are running on this yarn Hadoop yarn cluster we are running and this AWS cluster. And as you said that Azure, right? So even I'll provide you the knowledge at the last, right, about that. But that is also a separate course, right? Azure ADF.
Azure Data Factory.
Data Factory will say, right? Yes. So totally will deal with. But this is the course, right, which will be running on Hadoop yarn cluster, distributed cluster, right? Yes.
Hadoop Data Factory is nothing but Hadoop Data Engineering.
So totally on the cloud side, how we'll be performing, right? So that you will be discussing, right?
Both are same, sir. Hadoop Data Factory and Data Engineering.
So here totally we'll be discussing about this PySpark, right? So here will be our total concentration will be on Spark implementation by using Python. So where you run, see where you run later that your Spark APIs won't change, right? But all that where you are executing, where you are running, Spark APIs are not going to change, the built-in APIs of Spark. So that is implementing using Python. Actually, we have got multi-language support using Python, using Scala, using Java, and using our language. Mostly used is Python and Scala. So we are using as part of this course Spark with Python implementation. Right? Yes. PySpark, right? What are the APIs, right, of Spark in Python? Prerequisite for this course: knowing Python and SQL priority. Yes, basic what is that prerequisites means basic SQL knowledge is required. Basic Linux knowledge, but Linux not a problem. Basic commands, right? That one basic commands of Linux. I'll be briefing you about, right? One session I'll be spending on that basic Linux commands, right? Even if it doesn't have knowledge, you can go through. Fine. And basic Python knowledge is required. So yes, the course fee is 15. What is that? 12,000 for this, right? Yes. The course fee for Hadoop and PySpark, it is 12,000. But still, if anybody wants Python also, right, to be get up. Why? Because first I'll be discussing Hadoop, right? For the first 4 weeks, 4 to 5 weeks, I'll be spending time on Hadoop. So between that 4 to 5 weeks, right? If people want, anyone wants Python also, right? Yes, that is the course. We will be 15,000 for it. But we are excluding Python only if you want Hadoop and PySpark, right? It's 12,000, right? It's an offer batch provided, both technologies, Hadoop and PySpark combined, right? Yes. Yeah. Any other queries, right? Anyone? This is the course structure that you will be getting to your mail IDs, whatever mail IDs you have provided while joining the meeting, right? total Hadoop main components like Hive will be covered, Scoop will be covered, one NoSQL database will be covered, HDFS will be covered, part of MapReduce, right? Yes. And PySpark in brief, right? Data frames, RTDs, and DS streams, data streams, that is for streaming components, right? Yes. Fine. Yes. So we'll just have a break for 15 minutes, right? It's 5:30, right? At 5:45, right? 5:45 we'll meet, but at 5:45 everyone just follow the other link, right? Can you see the link in the chat panel, everyone? There is a link given by the online team, and also the payment details and procedures is given right in the chat panel, right? Yes. Payment details and procedures, right? Yes. So once again, I'm pasting that link, right? Yes, please follow that link, right? For the next after 15 minutes, we will be joining with the other link. Just join with the other link. Copy that link, right? Yes. The other link given in the chat panel, and also you can copy the payment process and procedures and other things, right? So we'll be having a one more session, right, of 1.5 hours up to 7 o'clock. Yes, and tomorrow the link will be changed, right? So you are supposed to get enrolled and registered, right? So tomorrow you will be getting the link to your mail IDs, those who got enrolled, right? Tomorrow a WhatsApp group will be created. Yes, fine. So I'm stopping now. Just we'll join the session after 15 minutes with the other link, right? Yes. Thank you all for your time. Thank you. We'll meet, right? Yes.